Hello everybody, welcome to this video. Today I'm gonna show you how to make this dynamic sewing effect with Blender, geometry nodes and the cloth simulations. You don't need to be a beast in vector math because we're gonna use some basic nodes and I'm going to make it as simple as possible. So yeah, let's move in. So here I am in a new file and I have already set up my camera and I have already set up my aspect ratio according to these specifications. We are going to start with a curve and jump inside the edit mode. Delete everything, jump inside your camera view and find the draw tool. And we are drawing our curve. Just like this. Now we can go inside the geometry node tab and add a new geometry node tree to this one. We are calling it curve modeling. And first we need to extrude that curve. So to do that, what we can do is use a curve to mesh node and use a curve line. We need to reset everything and find the axis we need. So we need to go on the x-axis. If we do that, it's going on the y, so we can just use the y-axis. And we need to extrude the same amount on each side, so we can just use a combine XYZ on both start and end, use a value, multiply the top one by -1, and plug everything into y. So now when we increase the value, we get the same amount on each side. Can go pretty high and adjust my points. I'm going to delete those one and shape my curve as I need. I'm going to set all my points to automatic with V and check automatic. Now I'm going to add a bit of depth by moving some points onto the y-axis and some other points behind too. If I display my wireframe, I can see that some edges are pretty close to each other, so what I can do is set the tilt of some points, either by pressing N and changing this parameter, or pressing Ctrl T and moving my mouse. So once I have something that I like, I can jump out of edit mode. And now we see we only have rectangles. So that's because this curve line is only made of 2 points. So we can resample it and increase the amount. And because we are going to use cloth simulations later, I'm going to choose something that's pretty high poly. And I can also resample the original curve to have some even geometry until I have some squares. And I can still move my points in order not to have too much overlapping geometry. All right, let's frame those nodes and call it modeling. Now what we need to do is separate the mesh right in the middle, split the edges, in other terms, and move each of the mesh island apart from one another. So what we can do, because we extruded the same amount on each side, is use the original geometry, group input, and we can turn this in a mesh, so curve to mesh, and use the proximity of those points to create a selection for the split edges node. If we preview the distance, we need to check first the points, or even the edges, because we get something cleaner. And wherever this distance is equal to 0, with an epsilon of 0.01, it's not working because we might not have any edges on there. So what we can do is just increase the resample curve until we have something, because sometimes the geometry isn't matching. So now we see we have our selection, so we can just plug that in the split and also frame those nodes. Call it splitting. And now essentially we created two meshes islands. So we can select one mesh island and move it apart from the other one. Let me show you. We have a node that is called mesh islands. And if we check the island index here, we can see we have island index 0 and island index 1. So we can set the position of the island index 0 and move it on X. So we have split our geometry. We can also move it behind or in front, however you want. Just try not to have some overlapping geometry and call it translate. So now we are going to switch to the closed simulation part. And in order to do this, we need to have a real mesh. So first we can duplicate this one, call it simulation, hide it real quick, and call this one curve modeling. We can hide it from the render and from the viewport and enable the first one. Now we need to apply this modifier, so Ctrl A, or just Ctrl A in the viewport and visual geometry to mesh. So now we have access to the geometry. Okay, so for the sewing to work, we need to have some connecting edges. And to do that, we can just select those edges, press Ctrl E and bridge edge loops. And we need those edges to be non-manifold, so we can just delete only the faces. All right, and now if I jump back out of the edit mode, we can add a close modifier, disable just for the demonstration the gravity, and enable the sewing inside the shape. So now the closed simulation is going to look at every non-manifold edges and connect them together. So if I press play, it's going to be abrupt, but everything is connected. You can play with the max sewing force if you want, set it to 0.1 and it's going to be slower, or 0.5 because it's very slow. And here you can see everything is connected. So what we can do, if we don't want it to start right at the beginning, is first pin those edges, so select them in edit mode, go inside the vertex group, create a new one, and call it pin. Assign those points to the pin group, jump out of edit mode, go inside your physics tab, and enable pinning. And now nothing is happening because those edges are pinned. So basically, vertex group are just black and white values. They are going from 0 to 1. If we go in edit mode, you see that you can assign a value that goes from 0 to 1. And in geometry nodes, we can play with those values. So let's say you have a mask that can disable the pin group gradually along the way. And that's what we are going to do. We are also going to create another pin group, because once we disabled the center pin group, everything might fall if we have the gravity enabled. So just create another one and call it sides and assign the sides of your geometry to it. All right, now we are set up. We can create a new geometry node tree and call it pre-simulation. And now what we need to do to influence the pin group is first extract a curve out of the group we made. So we can call the pin group we created before and use it to extract a curve from this mesh. So a mesh to curve and plug it right here. Right now you see that we have some useless geometry, and that's because it's extracting everything that's got a value of 1 on any point. So right now we have this point, and all the edges that are connected to this are gonna be used inside this. So first we can evaluate those points. We need it to be evaluated on the point domain, and we want it to be a Boolean, so we can get rid of those first points. And now we want to get rid of the non-manifold edges, and in order to do that, there is a node called edge neighbors, and we need to look at every edge that only have one face as a neighbor. So search for compare equal 1 and use a Boolean math set to end. Plug it here, and we extracted our curves because we are looking on only the points that are equal to 1 and the edges that only have one face as a neighbor. I hope that makes sense. We can frame all of this, call it curve extract, and now we can use the proximity of this curve to the original geometry to disable or enable the original pin group. So if we turn this curve to a mesh and use a geometry proximity, we want to look at the points. And if we preview the distance, you see we get a gradient. So what we can do is say everywhere this distance is equal to 0, we only get 1. And if we trim this curve before, we can play with the start, we are going to have some 0 here and 1 here. And you remember our pin group, which is going from 0 to 1. If we multiply 0 here, we are disabling the pin group. So that's what we are going to do. Use a map set to multiply and multiply our proximity setup onto the pin group. So now if I watch this, you see that everything that is black is going to be not pinned and everything that's white is going to be pinned. So we are revealing, sewing gradually the cloth. And now to confirm all of this, we need to write this as an attribute. We are still going to call it pin and just plug it here. So now just to verify, we can use our original cloth simulation, re-enable the gravity. And if I press play, select my geometry nodes, everything is falling. So I'm going to first, as I said before, add the edges onto this setup. So add, select the sides, and add it here. So now if I press play, something's wrong. Yeah, because I needed to go inside edit mode to refresh everything. But let me show you. If we go inside weight paint, we added the sides onto the original pin group. If I disable the add, it disappears. So that's this. And now if I play with the start, we can see that the middle is no longer pin. So let's check this inside of our cloth simulation. Press play. And set the max sewing force to 0. Press play again. And you see that it's responding accordingly. So now I can frame those nodes and call it pin modification. I can go at the start of my timeline, and first I'm going to set a shrinking factor of minus 0.1, so everything just pops out a bit more. And frame, let's say 30, I'm going to set a keyframe on the start of my trim curve, go at frame 170, set it to 1, and add another keyframe, and set all my keyframes to linear by pressing T with my cursor in the timeline. So now if I press play, everything plays normally, and the effect is already done. The first part of the effect is done, sorry. So now that I know that the effect is done, and I've done all my tests, I'm going to use a higher polygon count on the mesh. And in order to do that, we can just delete this one or disable it, re-enable the curve modeling, increase the subdivision count, or if you want, you can use a subdivide mesh at the end. Duplicate it, rename it simulation final, disable the modeling, and convert this one to a mesh, and redo what we did before with selecting this one, the middle part, set it to pin, assign, and the sides to a sides vertex group. Now we also need to bridge those edge loops, delete only the faces, and finally assign the pre-simulation node tree we did before. Also, to finish it, assign the close modifier, set the parameters however you like. I'm going to set them with those values. If you don't know what they do, you can just right click on it and select online manual, because you'll have some more detailed and explained way better than I can do it with the Blender documentation. So now we can also select the pin group, select the sewing group, enable the sewing, set a shrinking factor of -0.1, check if everything is working correctly. Everything looks fine. So what we can do also right before that is displace the mesh a bit, deform, displace, before the cloth simulation, create a new texture, set it to clouds, increase the size a bit, and decrease the strength. So now I can bake everything. Oh yeah, and we also need to add some forces. So I'm going to add a wind, set it to 5000 maybe. I'm also going to add some gravity force onto the negative y-axis, maybe like -5 meters per second. And finally, I'm going to use a turbulence with some trusty old drivers, hashtag frame divided by 60, frame divided by, I don't know, 50, and this one frame divided by 30. Increase the strength. And yeah, these are the values I used for the turbulence. So now I'm going to bake everything. Alright, so the bake is done. And we could have more folds, more wrinkles, but we need more geometry for this. And you can dial that in all you want. Alright, so now let's move on to the second part of the effect, where we need to have some strands, basically some points that are extruded from one part to the other of the mesh. So we can create a new geometry node, call it post simulation. And what we need first is to start from curves. So like we did on the first part of this node tree, we can copy paste this part of the node tree, and we are extracting some curves. And we need now another pin group because we added the sides onto the original pin group. So what we can do, because we still have access to the original geometry, is go in edit mode, select the middle part, and create a new group that we call keep and assign it to. So now we can just change pin to keep, and we got rid of the sides. Alright, so what we can do now is extrude one curve onto the other one. So we can use a extrude mesh, and first of all it's going to expect a mesh. So we need to convert these curves to a mesh, and we need to extrude the vertices. One problem we have is that it's extruding both of the curves, and we only want to extrude one curve onto the other. So to do that, we can separate the geometry, and we want to look on the spline domain because we are looking at curves first. And we want to separate them based on their index. So right now, because we only have two curves, we have index 0 and index 1 for the curves. That's index 0 and that's index 1. Alright, now the other problem we are facing is first we are extruding the vertices, but we are keeping those useless edges. So what we can do is turn this mesh to points, and those points to vertices. So now we are only extruding the vertices. Next problem is that we are not extruding onto the other geometry. As you can see, it's going not the way we want. So there is this socket here that lets us decide on which direction we extrude the mesh. Let me show you. If we use a combine XYZ and plug it into the offset, we can say offset only on the x-axis. But it's not as simple as this because they are not aligned. So we need a way to find the position of those points and tell Blender, tell this node, extrude only into their direction. And a simple way to do that, I'm going to show you in another file. Right here, I've got 2 points, point A and point B. And let's say we want to extrude point A onto point B. So first we can use an extrude mesh as in the other example. Set it to vertices, but it doesn't know where to go. So in order to know the offset, in other terms, the translation vector, in which direction it needs to go, we need to know the position of this point and subtract the position of this one in order to have the translation vector. So let me explain it to you. Let me write it to you. These points coordinate are equal to, so A equal 2 on X and 2 on Y. So 2X, 2Y, and 0 on Z. Point B is equal to 1, 2, 3, 4, 5, 6, 6 on X, and 4 on Y, 0 on X, on Z. So we need to move from A to B, and to know how much we need to move, we need to subtract A from B. So we need to do B minus A equals 6, 4, 0, minus 2, 2, 0. So it's going to equal to 4, 2, and 0. And if we look at our grid, we know that we need to move 1, 2, 3, 4 on X and 1, 2 on Y. So if we use the position, the current position, which is the position of point A, we need to find the position of point B. So we can, in this example, use an object info. You select object B. We need to find the position of this point. So we are telling Blender sample, look at the position, which is a vector of this point. The vector we are looking for is the position. And right now we only have 1 point, so it's index 0, but in the other example, we are going to look at all the indices. So we need to use the index node. So this is point B, point A, and as I told you, we need to subtract A from B. So vector math, set it to subtract, plug it like this, and plug all of this inside of the offset, set it the extrusion to 1, and voila, you have the effect. I select point B, I can move it how much I want, and every time A is going to extrude on B. So I hope this makes sense, and let's reproduce that in our original file. So we need the current position, which is A, the position of A. We need to look at the position of the point of B, vector position. We need to look at the position of all those indices, of all those points, and we need to subtract the current position to them. And that's our offset. So we can frame this, call it translation vector. Make sure this offset scale is always up to 1 because otherwise it's going to ruin the effect. We can get rid of the join geometry, and now we can displace those curves that we created in order to have a bit of organic effect. So we need to convert them back into curves, mesh to curve. We need to resample them because we don't have enough geometry right now. They are only made out of 2 points, so we can use any amount you like. Don't need a crazy high amount. And in order to displace some points, you need to use the set position. You want to displace them based on their normal, and we scale those normals using a noise texture. Plug it here, plug it into the offset, and now we are facing another problem. It's because it's displacing all of those points, and we only want to displace like the middle of those curves. All right, so what we can use is a spline parameter, and with this parameter, this node, we can find the factor of those curves. The factor is a gradient that goes from 0 at the base of the curve to 1 at the tip of the curve. But we can do more than this. We can use a color ramp, for example. You could use a float curve or, I don't know, something else. Add a stop to the color ramp, set it to white, and set the end stop to black. So now we have a selection that will allow us to only displace the curves onto their center. So you could either multiply this texture, or what I like to do is use another scale, because the scale here will allow us to set the strength of the effect. And if we plug this result into here, we can see that the sides are not affected. And we can now multiply this to decrease the strength of the noise. And you see that now only the middle is affected, so you can play with the scale. You could, if you want, set this to linear, add another stop, you know, play however you want with the contrast, but we are not going to, we need to move on, okay? You can do that alone. All right, so now if I press play, we are going to face another problem, and that's, we still have 2 points, and when the cloth is sewed, they are still displaced. So we could use something to also delete the displacement when it's on this part. And lucky for us, we created a pin group named attribute, which is called pin, and we can multiply, use this one, multiply that pin group onto the displacement. So now nothing is moving. What you could do also is move this map. So first set it to 4D and use a driver. You can also use a position vector mass set to add and offset onto the z-axis maybe by 500. And yeah, the effect is starting to take shape. I don't know. You get me, right? So what we can do now is frame those nodes, Ctrl J, and call it displacement, because as Ben Marriott say, we always label our layers. Same goes with nodes. Alright, so now we just need to add the mesh, and to do that we can just Ctrl Shift, right click and drag to get the join geometry, and we are going to add a bit more source to this effect, which is extruding the mesh. Because if we want to have some subsurface scattering later in shader, we need to have some volume. So we need to have some volume onto this mesh. So I'm going to isolate the mesh, and we want to extrude it. I don't want those non-manifold edges to ruin the extrusion, so I can delete them. And in order to delete them, we need to select them as we did previously in this video. So we can use edge neighbors equal and delete geometry. Plug the result of your selection inside the selection of the delete geometry. Set it to the edge domain, and we want less than 1. So now we got rid of these. Call it non-manifold delete. And now we can extrude. So extrude the mesh. We don't want to extrude any individual faces, but rather the entire mesh. And we need to extrude on both sides the same amount, because if I join this into the geometry, we can see that first we are lacking a face right here, but even though we could join it, we are going to see that the those strands are starting from the edges of the mesh, which doesn't make much sense to me. I'd rather have it start from the middle of the mesh. So we are going to use 2 extrude mesh and use the same trick as the beginning. Use a value, multiply by -1, plug this one on top, this one on the bottom, join those two together, and now we can increase the value here. And I'm going to go with something pretty low, like 0.005, and yeah, this looks alright. Now we can add even more stuff to this, which is like merging those middle edges, so it really sells the effect. And simple way to do this is merge by distance, and we need to increase a bit until this limit disappears. So right now it's not that high poly, so we can get away with this high of a value. But now you see the effect is working quite nice, and sometimes you get this kind of effect, but I didn't find a way to fix it. When you have higher geometry, it disappears. But for the sake of these tutorials, I'm going to stick with this amount of polygons, all right? And yeah, we also have this part that isn't merging, but to me it's not a problem because it's not in the camera view. Okay, so what can we do now? We could first do a bit of housekeeping. Hey, me from the future, and I forgot to show you that after extruding this part, if you check your face orientation, some normals are going to be flipped. So you need to identify where it's coming from and flip those faces with the appropriate node. So might be useful for you later, okay? Let's keep going. Extrude plus merge. And also subdivide the mesh so it looks a bit better. Subdivision surface. And now we can assign a material to this part. So set material. Create a new one that we are going to call cloth. Set it right here. And the final part of this effect is going to be using the new hair system that Blender is providing to us. In order to do that, we need to select our simulated geometry, press Shift A, go into curve, and use the empty air. By default, it's going to parent some curves, and they have a basic node tree. We can get rid of the first 2 nodes, use an object info node, and call our original geometry. Right now, it's going to call every geometry, but we are only interested in the curves that we made right here. Remember, all of these are curves. If I check here, I can see we have 251 splines. So let's jump back into this node tree, and there is a node that is called separate components. We only want to look at the curves. So if I isolate with // sorry, I can see I only have my curves. They look low poly when you're not rendered. You can adjust them right here, viewport display. But sometimes, you know, depending on the number of curves you have, it can slow down your viewport. So I tend to leave it to 0, because when you go inside of render view, Blender will automatically subdivide them. Right now we can see that they are way too thick, extra thick. So we can just use a SCR for set curve radius here, and lower the value, and we have our curves done. So what's cool with that is that because we have the original curve, now we can resample that curve and use as many curves as we need. You see, if you want to go like 250, 350, so that's quite flexible, you know, and you can do all sort of things, you know. If you want to have only 50 curves and have them have some that are equal to 1 and some that are equal to 0, which is a pretty lame choice if you ask me, but just for the sake of demonstration. Right here, the problem is that it's giving a random value on each point of those curves. And we want a random value based on each curves and not on each point of those curves. So to do this, we can use a curve info node and plug the curve ID into the ID. Because this socket, by default, is using the index socket. If I plug it here, and the index, by default, is using the point indices. This is going to use the curves number, the curve ID, and you have what you wanted. So let's go back in here, set it to 350, and set the minimum value to 0.005 and 0.01, 0.8, 0.2. So we have a bit of variation inside of the curves. So that's one thing. Now we can set a material, call it strands, curves, whatever else, set it here. And as a bonus tip, I'm going to show you that we can also store this value as an attribute to randomize whatever, the color, the roughness, the specular, anything you need inside of the shader. So we are going to call this rand, set it from 0 to 1 and store it here. So this will be our curves and shading. So now if we go inside our shading tab, we can get rid of this and use a principled hair BSDF. Get rid of the color. I'm going to go with some blue, I think, with the cloth. And because these are strands, I'm going to use a desaturated blue. But what I can do is use an attribute node and write rand. I believe that's what I wrote inside of geometry nodes. Yeah, I can still Ctrl-C, Ctrl-V here and preview it. And now we see we have some variation, so we can use it to drive the roughness, for example. And you have something, use it however you see fit, you know. I'm going to increase this radial roughness. And let's go back to our original, to our mesh. And also shade it a bit. So the strands I used, as I said, some kind of blue. I'm going to duplicate it here, increase the saturation. And this is ugly, so I'm going to change the hue a bit. Increase the roughness. Increase a bit the diffuse roughness because we are using some cloth. Increase the sheen. Use the same color but desaturated and a bit higher value. And check the roughness. Do it however you like. And I'm going to use some subsurface scalaring. And I can see that by default those values are used for skin. And it's expecting a vector, but inside of shading, vectors are also RGB values. You know, X is red, Y is green, and Z is blue. So we can use an RGB node, copy paste this color, desaturated, increase the value, and plug it inside the radius. And we can see we have something that's more logical to our original color. We can change the scale of the effect, however you see fit also, and same goes for the anisotropy. So now I can go back with my original scene world, disable this world, and I'm going to go inside a new tab because I have two viewports in here, and I'm also inside of my camera view. Now I'm going to add a light. I need to change it into a disk. I know that my camera is here. So I'm going to place my light onto a 45-degree angle on this axis, on this plane, and also on this plane. Target my cloth. I'm going to reduce the scale, the spread of my light here, because I want to have something more contrasty. And what I can do, because I don't like this angle, is rotate it around the 3D cursor. And place my light however I can. I'm trying to have something very contrasty, you know. I could use some HDR to fill the shadows, but I'm not going to do that right now because I'm a lazy idiot. I'm going to use another light instead, but make it less powerful. I'm going to fill a bit this part too. And now, to increase the contrast, I'm going to increase the power of this light. Let me adjust a bit the sheen, and maybe also the roughness. And yeah, this looks alright. So now what we can do also is a bit of compositing. So let's go inside the compositing tab, enable use nodes, and yeah, I'm not using the backdrop here. Okay, so just disable it because it's trash. Press Ctrl Shift to pop the viewer, create a reroute, and make yourself a bit of real estate. Now we are going to go inside of this tab and enable compositor inside the camera. So first what we can do is change the white balance. And there is a function right here which is called white point. You can change the temperature however you like, you know. Make it a bit more cold. After that you can change the exposure. Increase the exposition a bit. And after that we are going to do our primaries, which with a color correction node. We are going to only use this line, lift, gamma, and gain, shadows, midtones, highlights. I'm going to push my shadows right here until I see, as you can see here, I don't know why this node does that, but until everything is breaking. So I don't want any of these artifacts. I can also change my gamma to bring even more shadows inside of my scene, and increase the gain to make my highlights pop even more. Now what we can do is, if we want, depending on our colors, scene and stuff, we can increase the saturation. After that, what we can do is play even more on our shadows and highlights. So we can use an RGB curves. And right here, you've got your shadows and highlight adjustment. So we can push the shadows, as you can see. And push also the highlights. After that, we can do a bit of sharpening using a filter node. Diamond sharpen. We don't have any normal, so you know we are not gonna see a lot of stuff with sharpening. But what I like to do usually is first sharpen, and those values are depending of every project. But I'm just showing you those nodes so you can learn a bit more nodes inside of Blender and see how I color correct inside of Blender. After that, what I could do is use some lens distortion to create some chromatic aberration. Use the dispersion. And maybe what I can do before that is create a bloom. Use the glare node. Set it to, yeah, bloom, fog glow. Yeah, why not? Bloom, fog glow. Fog glow it is. We can increase the threshold because it's a bit strong at the moment. Oh, can do that now. You can adjust the strength too. Re-enable the lens distortion. And we want to find this chromatic aberration that we have right here. So it's specifically visible onto the edges that are the more, with the highlights that are more strong, that are stronger. I cannot talk again, sorry. We could also finish with a vignette. So for that we need to use ellipse mask, blur, and invert the color. Use a mix color. Set the mix to multiply, and first we need to preview our ellipse, increase the height, increase the width, check the blur, set it to relative, and increase the blur. So now we can decrease those values a bit. Check the invert, and no, actually we need to increase the width and the height. So now if we look at our final image, we can now reduce this value. And you see we are darkening the corners of the image because we are in something that's already pretty dark. We are not seeing it, but it might be useful for your future project. And the final touch is grain, so we can use a mix color, disable it first, use a texture, create a new texture, call it grain, open the texture tab, find the noise, plug the value right here, use the overlay mode, and it's destroying your image, so you just need to reduce the amount. Pretty sure you cannot see it inside of onto the recording, but at least I hope you learned some stuff. And yeah, guys, that's the effect, you know. Now you can, oh my god, that's the glare? What the hell? Oh, okay, that's the lens distortion. Oh yeah, because we have all those tiny stuff. Don't go too hard on it. But you know, that's my basic node tree for color correction inside of Blender. Sometimes I had a bit more, but if you don't do it a lot, I hope you learn some stuff. And yeah, guys, that's the effect done. Oh my god, that's way too raw, too glossy. You don't need the random. So yeah, guys, for the third time, yeah. That's all the effect done. I'm going to do a render to show it at the end of the video. All right? All right, guys, and that is it. I hope you liked it. I hope you learned a ton of stuff. I hope also that the translation vector explanation wasn't too much or too distracting or whatever. Feel free to tell me what you think about it. If you have any question, feel free to ask them in the comment, and as usual, I'm going to try to answer them as best as I can. Follow me on Instagram, on Threads, on X, wherever you like. Subscribe to this channel if you don't want to miss out on future projects. I'm trying to show you some simple ways to use geometry nodes in order to create some awesome projects. So yeah. Yeah, have a good one, guys. See you later.